Hi. What I like to do is introduce integration by parts. One of the topics done in the second term of a calculus, advanced placement calculus course. Before I do that, what I want to do is review the quotient rule, so we can see the quotient rule in action and how that quotient rule is used to understanding integration by parts. And the way to start that off would be find derivative of 5x e to the x. Well, that's easy. Okay, so dx of 5x e to the x. Well, let u equal 5x, u prime equals 5, v equals e to the x, v prime equals e to the x. And of course, working with what we know, we can say u v prime plus u prime v, which is u v prime 5x e to the x plus 5 e to the x. I'm finished. If we want to get fancy about it, we can say x plus 1, and there you go. There's your derivative. Well, let's look at what I have here. This is the part I really do want for you to understand. If we look at this closely, we'll get to see dx of uv is equal to u v prime plus u prime v. Okay, let's look at our Algebra 1 skills. Whatever you do to one side of the equation, you have to do to the other. So, if I integrate both sides of the equation, I can say uv is equal to the integral of u v prime dx plus the integral of u prime v dx. And if we use our skills from Algebra 1, whatever you do to one side of the equation, you have to do to the other. So let's look at what I can do here. If I subtract u prime v dx from this side, and I subtract u prime v from this side, I can say now uv minus u prime v is equal to u v prime dx. This is how we integrate by parts. Now let's go through one or two simple examples to show you how this works. And there's some really cool proofs that we can do with this. Let's say I ask you to integrate the example I had before, 5x e to the x dx. Well, again, we're starting with u prime, v, and v prime. But here's where we're going to be a little different. Let's call this u. And instead of calling this v, like we did for the product rule, let's name this e to the x. And now we're going to go through the steps all over again. Derivative of this is 5. The integral of e to the x happens to be e to the x. And now what we're going to do is follow along with the same logic that we had before. uv 5x e to the x minus u prime 5 times v 5 e to the x, the integral of that dx, is equal to the integral of 5x e to the x dx. And if we look at this a little more closely, we can say 5x e to the x minus 5, the integral of e to the x, dx, which happens to be 5x e to the x minus 5 e to the x plus c. We're finished. Let's try this again. Let's find the integral of natural log of x. The integral of natural log of x dx. Well, this becomes a little more difficult, but we're all forgetting that 1 happens to be a number. So let's say this is 1 natural log of x dx. Again, u v prime. Well, if I said u is natural log of x, u prime is 1 over x. If I would say v prime is 1, v is x. Well, let's look at what we have. U, v minus the integral of u prime v dx equals the natural log of x dx. And through substitution, we have x log of x log of x, minus the integral of v times 1 over x. That just cancel out, which is 1. You know, even though it's understood, I'm putting it in there just so you see it, which is equal to log of x dx. X log of x minus integral of 1 is x plus c. We're finished. That's all. We can do a lot of these. We can work on these working with trig. We can work with inverse functions, but they all work the same way. Go through these examples slowly when you first learn it, step by step. Do yourself a favor, make sure you put the u's and the v primes in and work from there. It's a step-by-step process.